In this video, we're going to do a couple examples where we have to determine whether a salt or an ionic compound is acidic, basic, or neutral. First thing I want to do is remind you about the relationship between the conjugate acid, conjugate base pair. The Ka of the conjugate acid times the Kb of the conjugate base is equal to Kw. So they're linked, which means the stronger the conjugate acid is, the weaker the conjugate base is, and vice versa. The stronger the base, the weaker the acid. Right? So if we look at this figure down here, if I have a strong conjugate acid, its conjugate base is neutral. If I have a weak conjugate acid, its conjugate base is also weak. And if I have a strong conjugate base, then its conjugate acid is going to be neutral. So strong goes with neutral, weak goes with weak. Alright, so our first example is ammonium chloride. Now I want to determine whether it's acidic, basic, or neutral. So the first thing we want to do is dissociate our salt. Right? So if I dissolve ammonium chloride in water, that's going to dissociate into ammonium ions and chloride ions. So the cation is always going to be either acidic or neutral. And to determine which one, I look at either the conjugate base, or in the case of a metal cation, I look at its hydroxide. The anion will either be basic or neutral. And to determine which, I look at its conjugate acid. So essentially what we're asking is, will the following reactions take place? If ammonium is acidic, then this reaction will happen. And in the case of the chloride, if it's basic, this reaction will happen. So, to determine, we look at the conjugate base of ammonium. So in this case, ammonia is a weak base. That means ammonium is going to be a weak acid. And so ammonium is acidic. And that means that this reaction will happen to some extent. In the case of the chloride ion, HCl is a strong acid, which means this reaction does not happen in the forward direction. HCl is a strong acid. That means chloride is neutral. Right? Which means the salt overall contains something acidic and something neutral. So overall, ammonium is acidic. Alright, so let's do another example. I want to know if calcium nitrite is acidic, basic, or neutral. So when calcium nitrate is dissolved in water, that will completely dissociate into calcium 2+ ions and nitrite ions. Alright, so to determine whether it's acidic, basic, or neutral, I know the cation will either be acidic or neutral. In the case of a metal cation, to determine that, I look at its hydroxide. So calcium hydroxide, we have to ask ourselves, is that a strong base or a weak base? This is one of the 8 strong bases. So calcium hydroxide is a strong base. That means that calcium 2+ is neutral. Alright? Now we have to consider the anion. It will either be basic or neutral. So again, I need to consider its conjugate acid. The conjugate acid of nitrite is nitrous acid, HNO2. Nitric acid, HNO3, is strong, but nitrous acid, HNO2, is weak. Weak acid. So that means its conjugate, the anion that we have in this problem, NO2 minus, is a weak base. So the salt contains something neutral and something basic, so the salt overall is basic. All right, third example, sodium nitrate. So when that dissolves in water, I get sodium ions and nitrate ions. All right, in this case, for the cation, it will either be acidic or neutral. So in the case of a metal cation, I consider its hydroxide. In this case, NaOH, because that is a strong base. That means that Na plus is neutral. All right, the anion will either be basic or neutral. And so again, I need to consider its conjugate acid. The conjugate acid of the nitrate ion is nitric acid, HNO3. Since that is a strong acid, that means that NO3 minus is neutral. So I have something neutral plus something neutral means the salt overall is going to be neutral.